I will hand over to Hugo. Thank you, Hugo.
Thanks, Sophie. So welcome, everyone. Thanks for joining us today. I'm just going to give a very brief sort of summary about sort of where we are and how we're doing with the project before handing on to the others, if that's all right. So, I mean, the good news is we're still more or less on the track that we set out at the last update. So things have gone through with a lot of hard work from everyone. I'd like to particularly thank all those of you who may have contributed to the working groups where people were asked to make contributions at sometimes short notice and rather awkward times. And it's been a huge amount of work from a very large number of people. So I'd just like to say big thanks to any of you who may have been involved in that. And thank you very much. So we managed to get the outline business case, which is the key document at this stage of the process, submitted in the time frame that we said that we would. Where it is now, it is currently with the New Hospitals Partnership, who are working through the business case. They are going to submit to us, judging by the meeting we had this morning, a barrage of questions on or about Christmas Eve, which we'll be required to answer within one day. Or risk. No, I mean, I'm slightly exaggerating, but not much. They're going to give us a large number of questions to answer within a very short time, and they want us to get back to them by Christmas, basically. So it'll be a pretty quick turnaround for the team. But having looked at the questions they've asked so far, none of them look like they're going to cause us huge problems to answer. There may be one or two tricky ones, and the devil will be in the detail, and we'll find out more later this week. Assuming that we are able to do that and get all our answers back to them, they then have to spend a few weeks mulling over what we've said. But they have a key committee meeting, which I think is towards the end of January, where they basically decide whether or not to recommend that this goes forward, and then our next key milestone is, at the moment, is the 5th of February, which is the Treasury Committee, which gives us the final sort of go ahead on where we are. So there's a lot to do between now and the end of December, and I expect subsequently. If the outline business case is approved, we will then progress on into the full business case, and I think Paul will tell us a little bit more later about what that will involve. But essentially, it's a much more detailed version, and we will be, identifying contractors, letting the contract for the building. It's really going to become very real at that point. And again, I'm afraid it's going to be a lot of work, and we may be asking people to come back with further thoughts on actually how we're going to use the building, and so we get it absolutely right, or as right as we possibly can on the date it opens. So I think the bottom line is, thanks to all of your hard work, we are still pretty much on track. Things are still moving at a very rapid speed, and it's entirely possible that we could be derailed by something or another over the coming months, but everyone's working really hard to try and avoid that. And at the moment, it looks pretty exciting. It looks very positive from the noises we're hearing back from all our partners and colleagues in the centre and so on. And there's a high degree of confidence and hope that this is going to proceed pretty much as we planned. So I think that's all I really had to say. But perhaps I might hand over to, I suppose our other big unknown at the moment is about the fundraising that we still need to do. So we still do have a bit of a financial gap, we still, one of the key things that we will need to be able to do is to satisfy the Treasury and the New Hospitals Partnership that actually we are going to be able to bridge that gap one way or the other, because they're going to make us an allocation of a certain amount of money and they won't want to give us any more. So that's one of our key bits of work, is demonstrating how we're going to bridge that funding gap, that philanthropic funding gap, and that is going to be a joint effort between our own hospital charity ACT and the university charity QDAR. So I'm going to hand over to Gemma to tell us how we're getting on so far.
Thanks, Hugo. Nice to see so many of the charity staff have joined us today to learn more about the Cancer Hospital. So hello everybody, I'm joining you from Addenbrooke's Charitable Trust. For those of you who don't know, we raise money for not only Addenbrooke's but also the Cancer Hospital and the Children's Hospital. To give you a bit of context about cancer, we've raised about £8 million since 2017, and that's about 5,000 people who've made gifts in gratitude for their care on the whole. So about 75% of the money we raise is thanks to your wonderful patients who are appreciative of their care. We look after them when they come and say thank you, and we make sure that we spend their money well. So in terms of cancer spend, for those of you that don't know, we fund lots of research in the hospital. We've funded updates to the Oncology Day unit, the new Haematology Day unit, which is probably 5 years old now. We've previously purchased 2 robots, and we've just completed fundraising for a 3rd robot, which will extend the service to 6 new specialties. The Personalised Breast Cancer Research Programme was given a springboard by ACT funding several years ago. So there's lots of different things that we fund. And I suppose that the most important thing to say is that while we are focused on fundraising now for the Cancer Research Hospital, we will still be funding the everyday needs in cancer and the rest of the hospital through our grants programme. That's still important to us to support as we go. So fundraising is a collaboration between Addenbrooke's Charitable Trust and the University of Cambridge Development Office. We have our specific fundraising targets that we've done feasibility studies to develop, and together we have the ambition to raise £70 million. Which seems like a big number, but we have lots of confidence that we're going to do it, but we definitely need some help from staff and patients to get there. So the way we're going about this is we are currently in a quiet phase, and that means that we're looking to secure major gifts, so some large gifts, whether they're 6, 7, or in the case of the university, hopefully 8-figure gifts. And trying to get some of those big building blocks in first. There's been a lot of planning and preparation to make sure we know that we have the right people to talk to about making gifts, and we're now out and about and having meetings with lots of people, talking to them about the case, talking to them about this incredible hospital, and hoping to convert those people to make pledges to support the hospital. So that bit comes first, when really we're talking to major donors and we're talking to grant making trusts. And we're also going to start to talk to patients and staff, because patients, particularly in oncology, are usually really helpful when it comes to fundraising. So one of the things that you'll see early next year popping up in different areas around the hospital are new fundraising hubs, where our staff and volunteers can start to talk to visitors about what we're funding now in oncology and how patients can help, but also starting to talk to people about the new cancer hospital as well. So we build up a database of people who are interested in supporting the cancer hospital. So where we would ask for staff help is, well, first of all, I'll say we will never ask you to ask for money. That's really important. Fundraising is about relationships, and it's about building trust with people. So while some fundraising is out with buckets or people jumping out of planes, basically our job is to look after people who come over to our office opposite A&E, and we look after them and we make sure we spend their gifts in the way that they would like to spend them. So the number one thing we ask staff to do is to remember that if someone says to you, I'd like to say thank you for my care, and they indicate they might like to make a gift, is to direct them to someone from the charity. And whether that's to our office opposite A&E or in our new fundraising hubs, then that is the absolute best thing that you can do. And I think being able to talk about the cancer hospital, if anyone asks you questions, is always the number one thing, because actually they'll probably have questions for you. And I think we might ask you, as of early next year, we might ask people to come and talk at events for fundraising, talk about your work, come and mix with people, talk about the project and what it means to you and to your patients. And then at a later stage, you know, staff have friends and family and acquaintances who are well connected. And if you have some ideas about connections we should be talking to, then you can always come and have a really quiet conversation with us. And if you'd like to get involved in fundraising, we'd always encourage you to come and have a cup of tea. We love meeting staff and talking to staff. We're always here in the office, so you're very welcome to come and ask us questions at any time. And that's all I was going to say, Hugo. I wasn't going to go too much more scary than that.
Great, thanks. And then is Nikki here? Nikki is here.
Yep. Hi, Hugo.
Hi.
Hi, everybody. I'm Nikki Murphy. I'm the Deputy Project Director for the Cambridge Cancer Research Hospital Programme. So I'm lucky I get to talk to you about something fun today. I normally talk about business cases. I'm going to talk to you about an event that we held, was part of the Comms and Engagement Workstream work, which was an event in Westminster on the 16th of November at the House of Commons. So as Hugo said, business cases are really important, and managing all our various stakeholders, but one of our key stakeholders are our MPs and the government, and making sure they're really aware of our project and also supporting it so that we can get through each stage of our business case and unlock that funding we really need to be able to build this hospital. So the comms and engagement team set up a Westminster breakfast event on the 16th. Key objectives were really to build the support with those MPs which we already have the relationships with, but also to broaden that. We had an MP event earlier in the year where we gathered them together for a briefing, and some of them signed a letter of support, which is really important to show the government how much we're really needed across the entire region, not just within the Cambridgeshire area. So objectives for the event were to raise awareness of the project, make sure everyone's really aware of where we'll get to, all the momentum we have, and how we're really ready to move forwards, to build that support, and also just to reinforce our positioning of Cambridge as centre of excellence, so that people really understand the global impact that both the Cancer Hospital and the Children's Hospital will have when we hopefully build both of these projects. So we had a really exciting event. Lots of us travelled down very, very early to London on the train for an 8:30 start. We brought together lots of researchers, clinicians, the broader team, so that we could meet with MPs face to face. There was a really exciting agenda, starting with a little bit of an introduction from Roland, followed by Jess Mills, who's the daughter of Tessa Jowl. So she came and gave us an update on the work that she does as part of the Tessa Jowl Brain Cancer Mission, and all about the importance of precision care, which is one of the really key things that we're going to deliver when we build this CCRH, building on what we're already doing in cancer services. Then we had some of our young ambassadors speaking. So crucially, this was a major projects event. It wasn't just around cancer, it was also around the Cambridge Children's Hospital and trying to make sure we get that across the line as well. So we had some of our young patients speaking, and also we had some of our cancer patients in attendance too. And that was I think it was really, really appreciated by all those in attendance. It really brought it to life and made it real. Then we had two final speakers, which were Nadia Godin-Heyman from AstraZeneca, again talking about precision medicine, and finally Michelle Mitchell from CRUK, she's the chief executive. So just really reiterating the leading science that we're going to be bringing together with our CCRH hospital. Research really meeting the clinical side. So how did it go, I suppose, is the question. We got lots of really, really positive feedback. We got some new relationships, and it was a great opportunity for the team to get together as much as anything and really make sure that we are creating those links across our research and clinical colleagues. We had some great attendance from local MPs, such as Anthony Brown, but also more broadly, Helen Watley, etc., from the Department of Health. So it was positive, and it was great seeing everybody face to face as well. There you go. That was it from me. I'm handing back to you, Sophie.
Thanks, Nikki. And we will hand it over to Paul, our design and construction lead, for an update on REBA.
Thank you, Sophie. Okay, I'll attempt to share my screen. Sophie, can we see that? Yep.
Perfect. We can indeed. Thank you.
Excellent. Okay. So I'm Paul Banks. I'm supporting Karin Charlting with the design and construction work stream, and that work stream clearly interacts with the other work streams across the project. So I'm kind of here today just to talk about where we've been during the REBA stage 3, the process, the outputs and procurement, but also just to look ahead to future stages. So we'll cover the overview of REBA Stage 3, look at the outcomes and the core activities during that stage, just talk through the process and deliverables through the stakeholder engagement, just talk briefly about the construction partner procurement workstream, and then look ahead to the later stages within the programme. So in terms of the REBA plan of work, so this essentially organises the process of briefing, designing, delivering, maintaining, operating and using a building into 8 kind of key stages. And I guess just for context, the outline business case was based on REBA Stage 2, which is here, which is the concept design. And REBA Stage 3 is the stage that we are currently in. This stage started at the middle of June, and CUH appointed a design team to develop that REBA stage, and that REBA stage concludes at the end of January. So in terms of the outcomes and the core activities, so we've appointed an architect and a mechanical engineer, civil and structural engineer, principal designer, and a cost consultant and a project manager. And they are the core consultant disciplines that form part of a design team, clearly with other specialist consultants, just developing that REBA Stage 3 and looking back at where we left REBA Stage 2, and making sure that we have a spatially coordinated set of plans on a floor-by-floor basis, but also making sure that we have a set of departments that are aligned through their clinical pathways, and that is coordinated with the stakeholders to ensure that we have a facility that we want to use, really. So clearly during that journey, the design team will be developing various design studies to make sure that we have fully coordinated, from an architectural perspective, but also in terms of a servicing perspective. So have we serviced the building correctly, and is it fully coordinated? Clearly, during that design process, we'll make sure that we will monitor any change through that design development, and clearly we will cost that change to make sure that we are aligning and reconciling back to the outline business case budget. Clearly, we'll be liaising with building control to make sure that we will have a regulated design and also building during this process. And clearly, all of this stage is underpinned by the design team's design programme, which then informs our master programme for kind of future stages, and how that master programme needs to coordinate at various milestones with the other work streams within the programme. Clearly, as design develops, we're looking ahead to a planning application which is on target for submission in January. But before we hit that date, we've clearly had pre-application meetings with the planners just to ensure that they're on this journey with us and they understand our design ethos, but we can listen to their comments, we can react to their comments and implement any changes necessary within our REBA 3 design to inform that planning application to make sure that we have a successful outcome. And then I guess lastly is the construction partner procurement strategy. So we're looking ahead to how we appoint a construction partner who will then further develop the design from REBA 3 and then build the facility for us. So in terms of process and deliverables, so in early summer, we were looking at how we develop the 1 to 200 plan drawings.
Paul, sorry to just Richard here. Are you trying to share slides?
Yes. Can you not?
Because I don't think anybody's seeing them unless I'm. Are we seeing them? I'm not seeing them. That's okay. Sorry to interrupt if people are.
That's okay. Can you see them now?
See
Richard?
them now, yeah.
Yep. Perfect. Shall I carry on? Perfect.
Yeah.
Okay. So yes, in terms of the 1 to 200 plan drawings, that sets out on a floor by floor basis how the CUH departments relate to each other, and also how the university departments on their floors relate. And those plans we've taken to the stakeholders, and we've engaged to make sure that we have the feedback to incorporate within this design stage, understand any changes required, and then feedback those signed off 1 to 200 plans back to those stakeholders. So from a 1 to 200 plan perspective, that concluded and was signed off towards the end of the summer. And in parallel with the 1 to 200 plan drawings, we were also zooming in on the 1 to 50 room drawings. So this is actually looking at a floor by floor basis and zooming in on the function of each room and the layouts within that room. We've been working with an equipment consultant specialist who will identify the equipment required for each room. And again, we've consulted with the stakeholders on a room by room basis, just to make sure that our users and our future patients will be happy with how that room is laid out, and also the equipment within that room. So again, the 1 to 50 room drawings were signed off at the latter part of the summer. And that then took us on to developing and loading those room plan drawings and developing the room data sheet. So we're moving from a 1 to 200, 1 to 50 to a 1 to 50 loaded plan drawing, which creates more certainty from a design perspective. So again, we're providing more certainty on the equipment, and also on the engineering services in terms of the heating requirements, the ventilation requirements, number of sockets, outlets, etc., so that we can provide that certainty for the users. And this stage has progressed from October through to later this month. So this concludes at the end of December. And the design team will conclude with an end of REBA Stage 3 report at the end of January, whereby the architect will coordinate as lead designer with the other design disciplines to make sure that we have a fully captured REBA Stage 3 design report that the users have signed off, and the PMO within CCRH have signed off also. And clearly, throughout that process, we've also been thinking about actually how should we appoint a construction partner to further develop the design and also build the facility. So this approach is on the basis of a two-stage design and build approach. We are utilising a national framework to procure a construction partner, and there are various stages in terms of the expression of interest stage, the tender stage, and then a pre-construction contract stage prior to a formal main contract stage. So we are due to receive the initial tenders back later this month, and we are targeting to appoint a main contractor around January, February time next year. And once we've appointed that main contractor, we will look to understand how we provide a target cost to inform the full business case later next year. So that kind of captures in terms of where we've been and where we are now. And as I kind of mentioned, our REBA 3 design process concludes around January, February time, prior to the approvals. Clearly, future design stages occur through here. We've talked about the planning application and the determination period. And then we've talked about actually procuring a construction partner, appointing them in early January, February time, and then entering into a pre-construction services agreement. And that will help us to inform the full business case stage here. And eventually we will start to build during 2024 and then operate in 2027. So that kind of concludes as to where we've been and where we are now, and I'll hand back to Sophie.
Thank you, Paul. So we will now hear from Professor Gilbertson with a research focus slot.
Hi there, I'm just going to share my screen and hopefully you'll be able to see it. If I can find my screen, there we go. Just let me know if you can see that okay.
We can, thank you.
Brilliant, okay. Yeah, so I've been asked just to give you a little bit of insight into the kind of research that we hope will transform the care of patients as we go forward into New Cancer Hospital. And this, I normally speak about other people's work, but this is an exciting piece of work that's just come out of my lab and published in the last month or so. And so the concept here is that cancer kills patients through metastasis. We know that. So 98% of patients who die of cancer die not because of the primary tumour, but because that tumour spreads around the body as shown here. So it has a propensity to spread outside the primary tumour site to the rest of the body. And so this is the work that, if I can get it to the slide to go, of my postdoc, Eric Roman. And the question we had is, if cancers don't invent anything new, so my lab's predicated on the idea that cancers don't invent new biology, they just use existing biology as part of the disease process. Therefore, the metastasis must be normal, which is a heresy really in terms of our current thinking of cancer, because the dogma in cancer has always been that metastasis is a completely abnormal process that only follows the presence of a primary tumour that then spreads around the body. So one way of thinking about this is we have always thought about our organs a bit like houses in a street, where the bricks are cells. And so if something goes wrong with the house in the middle here, then it has to be repaired from bricks actually added to the house, and you repair it with what's in the house itself. But what if those bricks or those houses were able to share their cells with one another throughout life, or repair each other with their individual bricks? And that's the concept that underpins this discovery, that essentially, unlike how we used to think about organs being very individualized entities with their own cells pretty much stuck there throughout life, our organs are a lot more plastic and are very likely to be sharing cells with each other throughout life. So just to quickly go through the story, a number of years ago, we identified the stem cell in the stomach, in the normal stomach, using genetic mouse models. And we showed that one gene in particular, when those normal stem cells became malignant stem cells, and this pink here is showing expression was lost, that actually this was a single ion channel called NALCAN. Don't have to worry about the details, but it essentially makes a pipe through the membrane of a cell that allows salts to pass through freely. Now, although that was exciting, it was exciting mainly because we saw that in human disease, looking at what's called the TCGA, which is a large amount of human sequencing data, actually this gene is mutated in many cancer types, including colorectal, gastric. We were interested because we'd identified it in gastric cancer in mice, and in humans this gene is mutated. Now, one of the challenges is, and this is a picture of the entire, what we call open reading frame of this gene. This is the entire DNA sequence of the gene. When you look at where those mutations happen in humans, they're scattered throughout the whole gene. And that makes it really difficult to understand what these mutations do, because if they're in what we call a hotspot, where there's a single point at which the mutation happens, that's relatively easy to understand what's going on. But when it's scattered throughout, it makes it more difficult. So working with the collaborators in Cambridge, what we were able to do is reconstitute, sort of make up this protein in a computer as if it would form in the membrane, and we made it in what we call a phospholipid bilayer to the cell membrane. And when the protein all scrunched up and folded back together, all these mutations were around the pore, that channel which allows salts to flow, suggesting that actually this was stopping the salts from going through. And indeed, when we modeled that, we were able to show that most of these mutations actually close the pore and stop it working, stop the salts getting through. And indeed, those mutations that closed the pore the most, so squeezed the host pipe the most, if you like, were found in the tumours that were most aggressive and had the most metastasis. So it started to suggest that perhaps this gene is important in metastasis. So what we did is we made a mouse where we could specifically delete this gene from any tissue we wanted. And because we'd seen this in gastric, intestinal, and other cancer types in humans, we made mice in which we knew they were going to get gastric, intestinal, or other cancer types. And we either kept that gene intact or we deleted one or both copies of that gene. And those mice would get intestinal cancer, gastric and intestinal cancer, or pancreatic cancer. And we spent about 6 years doing this project, and we found absolutely nothing, which is quite typical for science. So basically, there was no change in the primary tumour, and you don't have to worry about the details of this. And we also looked at great detail and all the histology of the tumours, and there was no difference at all. However, when Eric looked at the autopsies of these mice, and he did autopsies on over 500 mice, what he found is these tumours where we deleted this gene, just as predicted, were rampantly metastatic. Now we can switch a light on in these genes genetically so they glow green in these tumours, and you could see these metastases throughout all the organs in mice. And if you quantify this using this graph where the y-axis is showing the number of metastases, the dotted line just shows the background metastases in these different mice. And when you delete this gene, you massively increase the amount of metastasis, and that's represented by these heat maps over on the right-hand side. Now, a little bit worrying, if there are any images on the call, people who work in radiology, the natural blocker of this channel is a compound called gadolinium that we use as a contrast agent in MRI scanning. And when we gave mice that were wild type, in other words, had a normal channel, an MRI dose of gadolinium, they got rampant metastasis. And there is a concern from this work that actually the gadolinium itself that we've been using to image patients may well accelerate metastasis. So that's a scary side point. When we looked at the language that these cells were speaking as they floated around the blood, because actually we could see them in the blood of mice, just like metastatic cells in humans, we actually noted that they would overlap. This is just what we call single cell sequencing data. All you have to notice here is that these cells overlap with human metastatic cells. So they're metastatic cells in mice and they're metastatic cells in human. Now that's all very well. Then they went on and made tumours. The question is, what happens if we delete this gene from those same mice, but they don't have the genes that cause cancer, so they never get cancer? Well, when we did that, what was surprising is we saw exactly the same amount of cells being shed from the pancreas or from the stomach into the blood, just like they were metastatic. Not only that, we could find these cells in the blood very easily, as shown here, and they looked down the microscope just like metastatic tumor cells. Now, the funky thing is, when they went into the blood from the normal pancreas and from the stomach, they also metastasized, but rather than making cancer, they made completely normal tissue. So what you're looking at here is a reconstitution, three-dimensional image of a normal kidney from a mouse, in which we've activated green cells in the pancreas early in life and let the mouse age. And the remarkable thing is, by the time this mouse is as old as Hugo, these kidneys are completely replaced with pancreatic tissue. And we think this is going on all the time throughout life, and you can see it in the lung, as shown here, and in lots of other tissues. Now, if you look down the microscope by taking those green cells from a mouse, which is normal, but you've just deleted that channel, those cells have spilled out into the blood as if they were a metastatic cancer. Then we've taken a blood sample from that mouse, isolated those green cells, and then put them into another mouse. You can see them forming completely normal renal glomeruli in the kidneys and completely normal renal tubules. So what's very exciting about this, and another way of looking at this, is 3 dimensions. So this is a mouse that never has any of this going on. We've just given it these donor cells, and you can see a nice glomerulus here, and then all these renal tubules normal. So basically what this is doing is showing that these cells are also reconstituting the kidney. So the exciting thing about this science is not only does it give us a potential new route to understand metastasis, and we've developed a new drug approach we're developing a new drug approach to block that. But this, like sort of all the most exciting science should do, is give us insights into other things. So imagine if we could identify these cells, actually propagate these cells. Could they be used for patients with end-stage renal failure or lung failure as a way of repairing them? So just some things to think about. So is membrane depolarization, that's that SALT process, a target as an anti-metastatic therapy? And there are other issues that we think which you can answer questions on. We think this may explain so-called cancers without primary, so metastatic cancers that don't have a primary tumour and perhaps late relapse. There's a big question about whether we should use certain contrast agents in patients with cancer. And then the question is, have we able to repair tissues that are non-malignant using this approach? So I've tried to thank my lab as we've gone along, but particularly Eric, who's unfortunately kissing me in this picture, who did all of the work. So I'm going to stop sharing my screen now. Thank you.
Thank you, Richard. So now we have some time for a Q&A. So if you do have any questions, please pop your hand up using the reactions, or just come off mute and just pipe up, or you can pop them in the chat and we will read them out. So Hugo unfortunately has had to leave for another meeting, but we still have Paul, Nikki, Gemma and Richard from our panel who will endeavour to answer all of your questions. So do please shout if you have anything about any of the presentations or about the project that you have. Please do share them. Nikki.
Not sure if I'm allowed to ask questions as a panel member, but Richard, that was an excellent presentation. Thank you so much. How do you see this linking into the new hospital that we're building, and why is it so important that we have the CCRH?
Yeah, so that's a really good question. So basically, there's two main ways immediately. One is that obviously the cancer hospital will give us a markedly expanded ability to interact with patients in a research setting. And so as we hopefully develop new therapeutics for those patients, we will be able to use those in the hospital and we'll have space to do that. I think the other aspect in the Institute for Integrated Cancer Medicine, we've never really known what metastatic cells look like in patients. They're very difficult to isolate because it's always been thought that they're abnormal. And so the way we've been identifying them is basically looking at cancer, find stuff that labels cancer cells, and then try and find those in their blood. And it's a bit like a needle in a haystack. Now, because we can generate lots of these cells and they look very like human cells, we can start to really study these in great detail about actually what is a circulating tumor cell like, and therefore we could develop diagnostics, not dissimilar to the Grail type test that's being done at the moment. And again, that will be really useful to work with in the cancer hospital. And then I think the final thing is just the reach we will have. So Eric's paper went out online, and within two weeks, I think 23,000 people around the world had accessed it. And so it gives you an idea of the sort of reach that we can have in cancer across the world as well. And the Cancer Hospital will really help us with that.
Thank you. Any other questions? Samantha.
Hello there. So my name's Samantha Davis. I work for pharmacy in the transformation team. Just wondering, I've not been involved in any of this, but I know with the Children's Hospital, we were spoken to from the start on advice about the storage of medicines, you know, the regulations for cabinets and how we would lay out the rooms. I just wondered if pharmacy had been spoken to in terms of the cancer hospital.
I'm sure Nikki can add to it. Yes, thanks for your question. Extensively. So we've had at least 8 work streams throughout the process, covering all aspects from research through to sort of logistical processes within the cancer hospital. That's certainly been done, but Nikki, you might want to add to that.
Yeah, absolutely. And we're lucky enough to have Carrie Symington on the call as well, who is the improvement manager who sits within Directorate, who makes sure that we are considering and talking all tools the right people. So yeah, we've just gone through a process of user group meetings, and one of the key user groups we've been focusing on is pharmacy. We've actually got some external support in as well to help them to really understand the requirements going forward. So we are working closely with the team. Paul, Carrie, I don't know if there's anything you wanted to add specifically, having been on those user group meetings.
Yeah, do you want me to talk to that?
Yeah,
so yeah, Sam, obviously our paths haven't crossed, but there are 3 pharmacy areas in this building, and we've liaised directly with the leads for each of those areas, I guess. So Sunil's been quite involved as a whole, and then Lynn, the 2 Lyns for dispensing pharmacy and clinical trials. and then mostly with Kazim around the cytotoxic pharmacy, which has been the tricky one. But you will be very welcome to join in any of our discussions.
Yeah, we sort of mainly look at the storage of medicines in treatment rooms and in ward storage rooms. So, you know, making sure that the cabinets are metal, because a lot of places do tend to think that wood is acceptable where it's not, making sure the controlled drug cabinet is up to spec. And a lot of the things that we found in some of our surge wards was there was no worktop space for the nurses until we actually got in there. So it's just things that we've learned along the way, especially with the surge wards. You know, our experience is there, and we're happy to offer our services to you. So just to let you know, we're here.
That would probably be quite useful, because we have done some work on specifying that equipment, but hoping Paul's not going to correct me at this stage, we haven't chosen the exact cupboard. So I think we still have time to do that, and it would be really good just to learn from what you did on Surge. So I'll make a note, Sam, and get in touch.
Yeah, absolutely, that's great. Thank you very much for answering. Thank you.
Thank you, Sam. Reese.
Yeah, I have a research question for Richard. Apologies if you said this, Richard. I annoyingly had an Amazon delivery just as you were getting to the crux of your talk. Do you have any ideas what the sort of the normal biological process of bits of tissue moving around in the body is? And also, is the NALK protein involved at all in the sexually transmitted cancers, like the CTVT in dogs or similar cancers in mollusks and things?
Yeah, thank you, Reese. Good question. So I didn't talk about it because there wasn't time, but essentially there's a separate disease called nephrogenic systemic fibrosis, which is an all-wide, body-wide fibrotic condition. Mainly affects the skin and the kidneys, but all tissues can be affected. And it happens in patients who've had MRI scans and got gadolinium. And the reason I first got interested in it, when I was in the States working, my next door neighbour, who was an anaesthetist, had to retire early because he'd had a mini stroke. He was fine from that, but he got an MRI scan with gadolinium and ended up getting this body-wide fibrosis. And I think what this is, and then the reason for waffling on about that is because all our mice get nephrogenic systemic fibrosis. So we've demonstrated actually the cause of nephrogenic systemic fibrosis, which is gadolinium blocking this channel. But what it's doing is that we think that as an evolutionary response, you know, your body is full of stem cells. They're sitting on their backsides most of the time watching telly and doing nothing, right? So if you've got a sore foot and you need to mobilize a population of cells to help repair it that are what we call pluripotent, they can actually differentiate quite extensively, then why not mobilize cells in the gut or the pancreas to go and assist with that process? Because you've got so many stem cells knocking about that can do that. So we think that this is a repair process which naturally happens. And the reason why it gets ramped up is in nephrogenic systemic fibrosis is you've driven this to the point where now you've got massively excessive repair going on, which is basically fibrosis. So that's what's going on in nephrogenic systemic fibrosis. We haven't looked in specifically in the sexually transmitted diseases, but what I can tell you is that we've looked in other cancer types, particularly with Greg Hannon here in the CI. And interestingly, even cancers where this is not frequently mutated, like breast cancer, if you treat those mice that have non-metastatic tumors with gadolinium, they get rampantly metastatic. So I think this is a general process that actually governs normal cell trafficking, and it just gets caught up in the process with cancer.
Thank you.
Thanks, Reese. Thanks, Richard. Any other questions for anyone on the panel before we wrap up? Okay, if there are no burning questions, oh, Nikki, sorry.
First, just want to take the opportunity again at the end just to say thank you to everyone for coming on the call, but also just to say reach out to me, please. I'm nikki.murphy2@nhs.net and Carrie's on the call. Any of the team, if you have any further questions or anyone would like to get involved in the project or anything at all, then please do get in touch with us. The door is always open. Thank you.
Thank you, Nikki. Yes, I can verify they're a lovely team, and it's a very exciting project to work on. And yeah, we are very excited about next year and what's to come. Thank you all so much for joining us today. I will stop recording now and wish you all a Merry Christmas, and we will see you again in 2023. Thanks all.